Hello class, now we will do some questions based on congruency. So let's start. So in this question we have to tell whether the triangles are congruent or not. In the last video we have discussed about the various congruency criterias, or you can say congruency rules according to which the two triangles can be congruent. So let's check if they have any criteria which satisfy them. Now listen, this angle A is equal to angle P. Now I will write down that angle in A is equal to angle P. I can clearly see that both are 70 degree. I can also see that AC length is equal to how much? PR, because it is 3.5 centimeter and this is 35 millimeter, so both are 3.5 centimeter. So it means AC is equal to PR. Now one angle and one side I have got equal. Now if you remember those criterias, we can have a criteria in which two sides and one angle could be equal. Here only the length of one side is given, only the length of one side is there, so it means there can be no rule in which we need two sides, so SAS will be rejected. Okay, now we are looking for either AAS or ASA. We are looking for these two, because in these two only one side is needed, so we have one side AC equal to PR. Now this angle is 70, this is 3.5, this is 70, this is also 3.5. On this line AC, here we have got both the angles 65 and 70. Here we don't have this angle on point C. So now in this triangle ABC, by angle sum property we can find out measurement of angle C, because this is angle sum property. So therefore we can have angle C. Angle C will be how much? 65 degrees. So it means this angle is how much? 65 degrees. So therefore you can see that on this line AC, we have used AC here and this AC is equal to PR here. Okay, one length is equal, length of AC and PR are same. On AC we have two angles A and C. Angle A is equal to angle P, this is on length PR, and angle R is equal to angle C, so this is equal to angle R. So therefore there is a side which contains both the angles. AC, listen, I am repeating, AC, one angle is on C, one angle is on A, which are used here, angle A and angle C. In this PR, angle P and angle R, angle P and angle R are used. So it means this type of criteria is followed here. A side is there and on its two edges we have the two angles which are equal to each other. So by ASA, triangles are congruent. Okay, we can also use AAS here. How we can use AAS? If suppose I write down, I don't find angle C, instead of this what I do, I go for angle Q. I try to find angle Q from this triangle PQR. So from this triangle PQR we can say that this angle will be 35 degree. Now listen, there is a side AC, okay, there is a side PR which will be equal. Okay, there is an angle on A and other on P which are equal, okay, according to the new condition. So there is a side on which one of the angle is equal and one is the other angle. This angle 45 and this angle 35 do not have any relation with PR or AC, so in that case one angle is contained by the side and other one is different, so in that case we can use AAS. Okay, now one more thing is important. While writing down the congruency you have to be very careful. Suppose I want to see that ABC triangle is congruent to which triangle. triangle ABC is congruent to which triangle, you have to write down corresponding parts. What do we mean by corresponding parts? Angle A is equal to angle P. So suppose I write down here triangle PQR, suppose. Now all these points should be clear from this also. What I mean that angle A should be equal to angle P. So first point is A here, so first point should be P. Now we have got AC equal to PR, so first and third is AC and this is PR, so it means this point is also followed. Angle C should be, suppose angle R should be equal to angle R, so angle C is the third point, so angle R should be the third. So therefore we can say this is the correct form. You cannot write that triangle ABC will be congruent to triangle QPR. It will be wrong, because angle A is not equal to angle Q, whereas angle A is equal to angle P. You have to write down the corresponding parts. Okay guys, so now moving on to the next question. In the next question we have this figure, and whatever written in statement is here. So whenever you are asked to prove something, so first you will write down given part. The given part given in the question is AB bisected at C, or you can say C is the midpoint of AB and a perpendicular is drawn, so CD perpendicular AB. This part is given. So if you have done any construction, you can mention it here. Then you will write down to prove. What is to be proved? In this question AD is equal to BD needs to be proved. Okay, here we have not done any construction because AD and BD are joined in the figure itself, so it's up to you whether you write down construction as blank or not. Okay, you have not done any construction in this, so now we need to prove AD is equal to BD. Now we need proof of this. So in every time when you have to prove the corresponding parts equal in any triangle, you will take the help of congruency. Okay, suppose now we need to prove AD and DB as equal. So what it means, we need two triangles and we will prove that those two triangles are congruent, and then by corresponding parts of congruent triangles are equal. So we will apply this method to find out if AD is equal to BD or not. Now what is known, we know that angle P is equal to angle Q because each is 90 degree. To prove this, first select the two triangles in which AD and BD are their part. Okay, select two triangles so that AD and BD are their parts, and then prove those two triangles and congruent, and by CPCT. What I am saying, CPCT means congruent parts of congruent triangles are equal. Okay, so now we select the two triangles like triangle ADC and triangle BDC. So AD is the side of this triangle and BD is the side of this other triangle. So now we need to prove that these two triangles are congruent. So first we know that AB is bisected at C, so we will write down AC is equal to BC. This part is given. Also angle P is equal to angle Q because this part is also given, that CD is perpendicular to AB. Okay, now we can also see that CD is equal to CD is common to both the triangles. CD is equal to CD because CD is common to both the triangles. CD is part of this triangle and CD is part of this triangle also. So length of CD will be same. So now what we have got three things. What? One is the side, one is the angle, and other one is the side. But from here only we cannot write that by SAS triangles are congruent. But we need to see from here also that this is the AC which is involved. Okay, here AC is involved. Second part angle P is involved, and third part CD is involved. These are the three parts which we have taken: AC, angle P and DC. Similarly, from the other part, BC is involved, angle Q is involved, and this side CD is involved. So it means there is an angle between the two sides. There is an angle between these two sides. Similarly, P is the angle between these two sides. So if we have an angle between the two sides, so triangles are congruent by side, angle, side, because angle is being between the two sides. So triangles are congruent by SAS. So now write down the triangles, like triangle ACD suppose congruent to. Now you know that AC should be equal to BC. First thing is this, and this angle P is on point C, and this angle Q is also on point C of the other triangle. So it means while writing AC, we will write down this as triangle BCD. Why? Because from here you have to match whether AC is equal to BC or not. AC equal to BC, yes. Angle C of this triangle equal to angle C of that triangle. So C point should coincide, and then whatever is left, D point will cover D point. So these are the two triangles which are congruent. Now from this we can clearly see that this corresponding part AD is covered by the corresponding part BD. So it implies AD should be equal to BD, and this is by CPCT, congruent part of congruent triangles. Congruent, you know, congruent means the two parts will overlap each other. So according to the naming, what we have got, that AD will be covered by BD. AD will be covered by BD. So we have proved what is required, that AD equal to BD. C is wrong, it's BD. Hence proved. Okay, moving on to next question. So in this question, AX is the bisector of angle BAC. So if AX is the bisector, it means the angle BAX and angle CAX are equal, which are represented here as A1 and A2, because it is bisector. And the perpendiculars from P, perpendicular from P is PM and PN. So it means each angle is 90 degree. PMA and PNA are 90 degree. Now we need to prove that length of the perpendiculars are equal. So PM is equal to PN we need to prove. So now we are starting the proof. Again, select the two triangles in which PM and PN are their part. So these two triangles are in triangle PMA and triangle PNA. In these two triangles we will see which criteria is followed. So we can clearly see that PA is equal to PA is common to both the triangles. Also we know that BAX angle is equal to angle CAX, and it was given to us. BAX is equal to CAX is given. Also what we know that angle PMA is equal to angle PNA. This is also given as each 90 degree. Okay, so now what we have got two angles which are equal and a side. So now look at the figure. This side is used, PA. In this, PA is used, and from the above triangle we have used these two angles, this one and this one. Now one angle lies on the side and another one is not lying on the side. Okay, whereas in this triangle we have used AP, and in this triangle we have used A2. This is angle CAX, and this angle NPNA, which is 90 degree. So again in this triangle we have used AP, and these two angles, one of the angle lies on the side. So therefore we know that such a criteria is, what is the name of such a criteria? Triangles are congruent by angle side. Triangles are congruent by angle side. So now we need to write down the names of the triangle which are congruent. So triangle PMA is congruent to. Now we know that this angle M is equal to angle N, because each is 90 degree. So N will be the midpoint, and we know that this angle A, PMA, this A1 is equal to A2. So if A is the third point here, A should be the third point here also, because these two angles are same. So it means this is P. So PMA is triangle is congruent to PNA. So this A point coincide, M coincide with N when you will superimpose each other. So from this we can see that PM, first two is PM, will be covered by PN. PM is equal to PN by CPCT, congruent part of congruent triangles. Okay. Next we see the question. In this question it is given that AC is equal to BD, AC is equal to BD. These two lengths are equal, and AD is equal to BC. AD is this length and BD is this length. Okay. We need to prove that triangle ABD is congruent to triangle ABC. We can also show the corresponding parts which are equal by using this. One slash here, one slash here, so it means these two are equal. If I put 2 here, this will be equal to the line which has 2 slash, so this. So AD is equal to BC. This is the general method to represent. So now proof. In proof it is quite simple. First we will select the triangles which we will use. We need ABD triangle, it is given. Proof. In triangle we will discuss triangle ABD and triangle ABC. Okay, we will discuss these two triangles, and it is given that from ABD, BD is equal to AC, and from this AD is equal to BC, and both these parts are given to us. Both are given to us. Okay, now two things are equal. Okay, so we need one more thing, because all the criteria set need 3 things: 2 angle, 1 side, 3 side, or like that. So now we can clearly see by the name itself that AB part is common. AB part is common to both the triangles. So AB is equal to AB, which is common. So all in triangle ABD we have 3 sides, and in the ABC we have all 3 sides. So 3 sides of this triangle is equal to 3 sides of the other triangle. So triangles are congruent by SSS. And how we will write down? You have to be very careful while using this symbol, because the one-to-one congruency should follow. Now AB should be equal to AB. So one can see that we can write down ABC. Now if we write ABC, try to check whether this thing follows or not. Now AB is equal to AB. This part is followed. AD is equal to BC. AD is this and BC is not this. So it means this is not the correct way to write it as. So correct name is triangle ABD is congruent to triangle BAC. So the two triangles are congruent by SSS. Next question we will do. Now in this question it is given that triangle ABC is isosceles, and we know that what isosceles means. Isosceles means that 2 sides are equal, and it is given that AB and AC are equal by this representation. So if AB and AC are equal and triangle is isosceles, we know that base angles are equal. Base angles of an isosceles triangles are equal, so angle B will be equal to angle C. It is also given that AD is perpendicular to BC. These 3 things are given to us, and we need to prove BD is equal to DC. Construction part no need to write, because we are doing no construction. So now the proof. So first BD equal to DC we need to prove. So we have to select the triangles. So we are looking in triangle ABD and triangle ADC. So in these two triangles we know that AB is equal to AC. It is given. AB is equal to AC is given. Angle ADB is equal to angle ADC, and each is 90 degree. This is also given. AD is perpendicular to BC. And we can also see that AD is equal to AD is common side. AD is equal to AD is common side. So now in these two triangles, if we see here, we have used this length AB, and from here we have used AC, Okay, we have used the angle ADB. ADB is this angle, and ADC is this part, and AD equal to AD is common, so this part is what we have used in both the triangles. So you can see one angle is 90 degree. Okay, this part is the hypotenuse of this triangle, and this part is the hypotenuse of this triangle. Okay, and this is the other side of both the triangles. So clearly by RHS, because in RHS we need a right angle, the right angle is there. Hypotenuse we need, yes, both the sides AB and AC are hypotenuse of their respective triangles, and one other side is AD. So by RHS, triangles are congruent, and if we write the name ABD is congruent to triangle ACD, these all the parts will be followed from this only. So from here we can see what we need. BD, last two should be last two, so BD is equal to CD by CPCT, hence proved. Okay, thanks for watching. I hope you will like the video, and don't forget to subscribe the channel. Thank you guys.